Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. If you are new here, kindly share, like, subscribe and comment for more interesting videos and updates. Now, one of the subscribers, tested me with this question. And the question reads, identify the following functions under odd or even and indicate their symmetry. So the function I was given in this case is sin x, cos x, and tan x. Now if you are new here, kindly visit my previous lecture videos on even and odd functions. But because of this question, let me just do a little bit of recap before we can do justice to this question. Now, even functions, so even functions. Now, if you already know the formula, right? So if you have f of x this way, which is equal to f of negative x, if this is equal to that, in other words, if the left hand side is equal to the right hand side, then it is what? An even function. Is that also good? So now the whole idea is this. If you have x, you are simply what? Replace x with what? Negative x. And now we will now want to look out for the response. But in this case, we are not going to focus on control systems or system controls and dynamic systems, right? Or system dynamics. So here we are going to do mass here. So our response here will just be called an output. So if I have x and I replace the x with negative x, now the output is always what? Is always positive. Example, for instance, if I have, let's say, f of x to be equal to, let's say, 2 raised to the power, let's say 2. What do I have? I have what? 4, this way, right? So if I have, now I want to replace x with negative x. So I have negative x over here, which is equal to, so I'm going to negate this, right? So I have negative 2 here, all squared. What do I have? I still have what? 4. To get that, so for even functions, the response, the output, is always what? The same. When you even replace x with what? With negative x. As simple as that. So far as this equals this, then it is what? It is an even function. To throw more light on this, what is the geometric definition or the geometric meaning of even functions? Now, when I plot or when I have my Cartesian coordinate system, or if I have my rectangular coordinate system this way, x and y, which is equal to f of what? Of x. Even functions, they are symmetric about the y-axis. Something like this goes, look. So this is the geometric definition for even function. What do we mean when we say it is symmetric about the y-axis? What it means is this. Now we have this graph this way, This is not drawn to scale, Pardon me for that. But when you take or when you consider the left-hand side of the graph, it's the same as what? As the left-hand side of what? Of the graph. In other words, there's what we call mirroring, Whatever is here appears to what? To be here. The same thing. You get that? That is for even functions. So for even functions, they are symmetric about what? About the y-axis. See the question? And indicates what? Their symmetry. So before you can attempt simple questions like this, you should be able to appreciate the little ones over here. Then you just do application. Now let's talk about odd function, right? So if the function is not odd, it's what? It's even, right? So if that is the case, let's see. Okay, for the odd function, okay, a function is said to be odd if and only if f of negative x equals negative f of x, right? So the whole concept is this: when you replace x with a negative x, okay, x with negative x, now the response or the output of the signal is negative. But for even, when you replace x with negative x, the response or the output of the signal is what? Is the same. Is that also good? So for example, if I have f of x to be equal to, let's say, x to the power 3. So if I want to evaluate f of, let's say, negative, let me pick 2. So this is the same as what? I have negative 2 raised to an exponent of what? Of 3. Wherever you see x, you put negative 2 there. You get that way here. Then raised to an exponent of 3. So what do we have here? We have negative what? Negative 8. But let's consider this. If you have, let's say when you have something like f of x, which is equal to x to the power 3, and you want to evaluate f of positive 2, which is equal to, what do I have here? Wherever you see x, you put 2 there, raised to an exponent of 3, right? So what do we have? We have 8. Why am I doing this? I'm doing this to confirm to the statement that when you replace positive x, okay, positive x here with what? With negative x over here, the output or the response are not what? Are not the same. As simple as that. So far as Tindanious Maths and Science YouTube channel is concerned, we don't have to memorize, we don't memorize maths, okay? Let it become part of you, because we want to solve real life problems in what? In future. Alright? Good. Now, what is the behavior of this geometrically? So for all functions, okay, it is symmetric about their origin. Please do not say even functions, they are symmetric about the y-axis, while odd functions are not symmetric about the y-axis. No. So even functions, they are symmetric about the y-axis, and odd functions, they are what? They are symmetric about the origin. So it has to pass through what? The origin, okay, right? So for all functions, okay, it is symmetric about the origin, while for even function, it is symmetric about the y-axis. Do not say for even function it is symmetric about the y-axis, and odd function they are not symmetric about the y-axis. That's not the case. So while even functions are symmetric about the y-axis, odd functions they are symmetric about what? About the origin. What it means is this. So if you have your graph, okay, and you rotate your graph by 180 degrees about the origin, that is simply the odd function. So here, there's the origin we are talking about. So from here up to here, that's what? That's the 180 degrees what? About what? The origin. That is simply the recap under even and odd functions, okay? Example, if you have an even function, okay, even function, let me consider the cos function, cos x, though we have it over here, right? So if I have cos x over here, cos x, is it even or odd? Let's do some testing. We know that for even function, we have f of what? Of x to be equal to what? F of negative x. If this is equal to this, then it is what? An even function. So if I take, so let's say f of x is equal to cos what? Cos x. What about f of negative x? So have cos, wherever you see x, you put negative x over there. So I have what? Negative x over here. So this is equation 1. But we already know from trigonometry that when you have cos theta and you have cos of, let me do it this way, cos of negative theta, and you have this negative cos theta this way, this is negative angles under trigonometry, right? So if I have cos of negative theta, okay, when I evaluate it or when I compute this trigonometry, right, function, then I'll have this cos theta. In other words, cos theta is equal to what? Cos of negative theta. The same way if I have from trigonometry, okay, if I have sine of negative theta, I'll have negative sine theta this way. So why are they so? They are so because this is what? This is an odd function, and this is what? This is what? An even function. So viewers, when I compute this, you already know the results now, right? This, I'll have what? I have cos of what? Of x. This is what? Equation 2. So we can now say this f of x from equation 1. Okay, are the results the same? Yes, they are the same, so I can equate them. So I can therefore say that f of x is equal to what? F of negative x. Hence, cos function is what? Is an even function. And clearly, sine function is what? Is an odd function. So let's do justice to the question on the board, okay? So if I have my trigonometry function this way, I have sine x. I have sine x here. I have cos x. I have what? Tan x. So this is the function given in question, right? And the same should state what? Whether it's even or odd, right? So let's say the function type, okay? So let's say the type of function will be here. And their symmetry, right? So I have symmetry, okay? Now, viewers, clearly sine function, is it odd or even? This is what? This is odd. From here, is it? This is what? This is odd. And from here, the cos function is what? Is an even function, right? Equation 1 and equation 2. So cos is what? Is even. Over here, even. Like this. Then tan, okay, is also odd. Then, okay, let me include the rest. So sine, cos, tan, let's consider sec x. Then what should I consider again? Let me consider cos x. And lastly, let me consider cosec x this way, right? Though she asked for 1, 2, 3, but I want to add the other 3 just in case you can encounter questions like this, okay? You should know what to do. So for sec x, is it odd or even? This is even. So for cot x, is it odd or even? This is odd. And cosec x, the function, okay, is also what? It's also odd. Now, before you can tell the symmetry of a function, you should know the type of function it is. So if you are saying sine x is an odd function, then odd functions, they are what? They are symmetric about what? About the origin. So this is what? Origin. Then this is what? This is why it is even symmetric about what? The y what? as this. So y what as this. As simple as that. So you don't need to memorize this. So you use the type of function to what? To know the symmetry, right? So odd, so far this is odd. Odd is what? Then we have origin this way. This is even, right? So this is y what are this. Then this is odd, right? So far this is odd, then this is what? Origin. Then this odd function too, right? Is symmetric about what? The origin. As simple as that. Viewers, this is the end of the tutorials. So far as Tindanious Maths and Science YouTube channel is concerned, we are going to learn a lot. Bye.